Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 11 students and the topic of discussion is statistics. This is an introductory video on this topic. So first we define what is central tendency. It is a quantity measured to know where the middle center of a bunch of data lies. Let us try to understand this with an example. Suppose in a class, these are the marks obtained by students out of 10 and so on in a subject, say mathematics. Now we want to know like what is the central value or the average of marks obtained by student by one number. Instead of defining so many numbers, with one number can we say some information about this data. That is called the average or the mean value or the central tendency, we call it as. This can also be written in terms of median or mode. We'll try to see this with more examples. Now consider two batsmen A and B whose last 10 inning scores are given by these numbers 29, 91, 0, 53 and so on till 71. Similarly for batsman B, his scores in last 10 innings are 53, 46, 48, 50 and so on. Now we need to give information about this number with a single value, like what is the average or what is the mean of these numbers. So mean means adding all the numbers and divided by the total number of numbers, like 1 2 3. There are 10 numbers here, similarly there are 10 numbers here. If we add all these divided by 10, will give mean as 53. Similarly for batsman B, if we add all this and divide by 10, we get 53. 10 is number of data here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what do we understand by this? We see that the mean scored by batsman A is 53. Similarly, mean of score scored by batsman B is 53. What else we can get? Similarly, let us try to find the median of these scores. So medians means writing this number first in ascending order. It can also be in descending order. So we write 0, 5, 2, 29, 31 and so on till 117. Similarly for this batsman also we rearrange the scores in ascending order and we find the central value. Central value is, since it is an even number, there are 10 scores, there will be two central values. If this was an odd number, then there will be only one central value. Since it is even number, these are even numbers, there will be two central values. How do we get? So 10 divided by 2 is fifth value and n by 2 plus 1. Fifth and sixth values are the central values. So we take, these are the two central values, we find the average of these two gives the median as 53. Similarly, these numbers also we arrange in ascending orders. There are 10 scores, so n by 2 is fifth and sixth score, and taking average of these two values will give the median as 53. In mean we have seen that we took average of all the numbers, like 117 also was there, 0 also was considered in finding the average. But in median we ignore the extreme values. We are not worried whether this is 0 or 10 or 8 or this may be 150, it will not affect the median. So this is very important. Median is ignoring the extreme values. Now let us find the mode. Again we arrange the numbers in ascending or descending order. We see that mode is the most frequently occurring data. So in this 53 is occurring more, so mode is 53. Similarly here also 53 is occurring 3 times, so mode is 53. So in the present problem or in the present example, we have seen that mean, mode, median are all equal to 53. Is it necessary that mean, median and mode be equal? No, it is not necessary. In this particular data or in this particular problem, mean, mode and median are happen to be same. It need not be same. Now we go a little more deeper into the data. So this was the inning score by batsman A and this is by batsman D. Let us plot on a number line. So we see that the scores on the number line are like this. These are mapped into the number line. Like 0, 30 is mapped here and so on. And similarly for batsman B also it is mapped on a number line. What do we find? We find that these scores are more scattered on the number line. Similarly, these scores are not much scattered. It is closer to 50-60 range. So what we can conclude, there is more variability into this data or there is more dispersion into this data. In this data, dispersion is less. This is very important. We will see further what is dispersion. So dispersion is variability in the data or the scatterness of the data. So there are different types of dispersion: range, mean deviation, standard deviation and quartile deviation. We will try to discuss this one by one. So what is range? Range of a series is maximum value minus minimum value. For example, for batsman A, these were the score. The maximum value is 117 and the minimum value is 0. So range is maximum minus minimum equal to 117. Similarly for this batsman also, maximum value is 60 and minimum value is 46. So range is 60 minus 46, 40. What does it gives? It gives a rough idea of variability or scattering. This shows that the scattering is more while this data shows scattering or variability is less. However, range does not tell about the dispersion of data from a measure of central tendency. This is not telling how much it is away from the mean. Similarly, this is also not telling how much it is away from the mean. So we'll try to find out a technique or some method which tells deviation of data from mean, how much it is scattering from the mean. That is, we come to the first understanding called as the first point called as the mean deviation. So what is mean deviation? As the name suggests, we have to find a number which is away from the mean. How much data scattering is away from the mean? That is the simple English understanding. Like marks in a maths test is given by 6, 10, 13, 15, 16. So we first find the mean of this data. Mean is adding all these and divided by 5. We get x bar as 12. This is mean. And now we need to find mean deviation. How much is data is deviating from mean, each of these data. So 6 minus 12, these are the data written here. They are called xi's. This is xi. 6, 10, 13, 15, 16. How much it is deviating from mean, that is called di. So 6 minus 12 is minus 6. 10 minus 12 minus 2. 13 minus 12 1 and so on. Now mean of deviation is sum of the deviation by number of observations. There are 5 observations and sum of deviation, if we add sigma di, minus 6 minus 8, positive is also 8, so this will be 0. So mean of deviation is 0 by 5 equal to 0. Now it is telling there is no deviation from the mean. But however, we see one mean is 12 and there is variation. This data is 6, this is 10, this is away from mean. So how do we get this as 0? So mean of deviation using this methodology is not a proper way. We have to find out some better way of finding the mean deviation. That's what we'll do next. Here we find the sum of absolute value of deviations. by number. We found this deviation in previously we have seen deviation from the mean is -6, -2, 1, 3, 4. If we add all this, it was becoming 0 and mean deviation was becoming 0. Now what we do, we take absolute value of this. So if we take absolute value means negative will become positive. This symbol is absolute. Two parallel lines like this showing is absolute symbol. So -6 will become 6, -2 will become 2, positive will remain positive. So absolute of a number is the negative will become positive and positive will remain positive. So if we add all this now, 16, so this will be 16 by 5. So we get 3.2. This makes more sense. Now mean is 12, it is telling the data variation from the mean is 3.2. So that makes some sense. If we say 12 plus 3.2 is closer to 16 and so on. So this data is somewhat meaningful than finding without using the absolute value previously. So it is important you take sum of absolute values and not sum of values of deviation. Not this column, but we need to take absolute values in computing the sum. So this is one definition of mean deviation. Now you may be wondering whether we have to take this deviation from the mean value we have taken earlier. Can it be median or any other central tendency like mode also? Yes, the answer is yes. Mean deviation can be taken from any central value A. It can be mean or it can be median also. For example, this sigma equal to 1 to n mod of x minus x bar by n. This we have seen, mean deviation about mean. Previously we have seen. It can also be about median. Median deviation is sigma equal to 1 xi minus m. This mod is there. Here capital M is median. So mean deviation can be from mean or it can be about median. So far we have seen ungrouped data. Now we come to group data also. What is group data? Group data means it has a frequency. There are two types of group data. One is discrete and another is continuous. In discrete we have xi and fi like this. xi, fi, xi, fi. This is a discrete group data. In continuous group data we will have the class intervals. We will see that later. So in the discrete group data, we can find the mean deviation by 1 by n, 1 by capital N, where n is sigma fi into x minus x bar. So what is the difference between these two? You can compare here. In the ungrouped data, this was the formula being used. 1 over n sigma I equal to 1 to n x minus x bar mod. Sum of the deviation absolute values will do divide by total number of observations. But in group data or discrete group data, we multiply with fi also. You see fi term is also coming. So what does this mean actually? Xi fi, what does physical it means? It means, for example, you assume these are the marks obtained by students in a class. So frequency means how many students got, like 10 marks 4 students got, 30 marks 24 students got, so 50 marks 28 students got, and so on. So fi is the frequency of occurrence. So let us try to find mean deviation for this data. Xi fi is given. Now we have to first find the mean to get the mean deviation. So what is mean for a group data? Discrete group data is 1 over n sigma fi xi. So we multiply each term fi xi, we get this sigma is 4000. So 4000 by sigma fi, that is n. Sigma fi is n. 4000 by 80 is 50. So we got the mean value. Now we find the absolute deviation for each data. So 10 minus 50 is minus 40. Absolute value is 40. 30 minus 50 is minus 20, absolute value is 20, and so on. Now we got mod of xi minus x. Now we have to multiply this with fi. So we multiply this with fi and get it like this. 4 into 4160, 24 into 2480, and so on. We find sum of this 1280. So we got, now put it in this formula. This is 1280 divided by n is 80. So 1280 divided by 80 is the mean deviation about the mean. Mean deviation about the mean is 16. 1280 divided by 80 is 16. Now let us find the mean deviation about the median. I have taken one NCERT example here. Here again xi and fi, this is the input given to you, 3, 6, 9, 12. This can be assumed as some marks by students in a class, and these are the number of students who got those marks. So for example, the marks obtained is 9 by 5 students. The marks obtained by 2 students is 12. The marks obtained by 4 students is 13, and so on. The first step in finding the mean deviation about median is to get the median. Then the procedure remains same. So how to get median? First we need to find cumulative frequency. So we write the CF also here, that is cumulative frequency. Keep adding frequency terms. So first value is 3, then 3 plus 4 is 7, 7 plus 5 is 12, 12 plus 2 is 14, and so on. So if we add all these values, we get 30 as the cumulative. This is capital N, or the number of observations, 30. So n by 2. N by 2 is 30 divided by 2 is 15. So since it is a even number, there will be two middle values, 15th and 16th. And we have to take average of 15th and 16th value. But where is 15th and 16th value? Only 14th value is there. So next value is 15th. So it will come to here. So always take average or the median values from the exercise. Please do not pick from FI or CF. Mean, mode, median are for these values. This is very important. So we have to take average of 13 and 13 to get the median. So median is 13. Why 13? N is 30. So n by 2 is 15th value. 15th and 16th value is 13 and 13. Why this is 13? This is up to 14th value. So 15th value is 13 and 16th value is 13, which is less than 18. So median is 13 plus 13 divided by 2, which is 13 itself. Once we have found the median, the mean deviation finding remains same. Now we have to find xi minus m mod. So xi is 3, median is 13, 3 minus 13 is minus 10, minus 10 mod is 10. Similarly, how to find this? 6 minus 13, this is xi, median is 13, 6 minus 13 is minus 7, mod of that is 7, and so on. Now this is xi minus m mod into fi. We have to do fi is already we are picking from here, and multiplying these two we get this. Now we know that mean deviation about median is 1 over n sigma fi into x minus m. This sigma is 149 divided by 30. Capital N is 30 is 4.97. So what does it physically? It means that the median for this data is 30. Sorry, median for this data is 13, and its deviation from the mean for each data is about 5 or 4.97. I have roughly taken as 5. So it makes sense. Median is 13, around 13, and deviation is about 5. Sometimes we have to use a method called as step deviation method in computing the mean. This is for continuous frequency distribution where you will have the class intervals. So what is the step deviation method? X bar equal to, this is mean, x bar equal to a plus sigma equal to 1 to n fi di by capital N into h, where h is some scale factor, D is the deviation. For example, this is the deviation we have computed here for a assumed mean as 60, and we computed the deviation as this. If we see that there is a factor of 10 in this, so we can divide this by 10 each. So deviation can be -6, -5, -4, -3, and that scale factor can be 10. So this is 10. This is the deviation -6, -5, -4. Fi is the corresponding frequency. A is the assumed mean 60 here. So this step deviation method can be used to find the x bar. Once x bar is computed, we have standard formula to compute the mean deviation. How to find mean deviation about median for a continuous frequency distribution? So we have a class interval here. We have a frequency given here. So first we compute the cumulative frequency. We see that total n is 40. So n by 2 term is 20th, and where does it lie? 20 and 21st term. It will lie somewhere after the 14th and before 25th. So it will lie in this class interval. So our class interval is 8 and 12. So we use this formula to get median for a continuous frequency distribution. Mean equal to L, where L is lower limit of median class, which is 8. This is the median class, and median class is selected by the n by 2, n is 40, 20th term, which is after 14. So it belongs to this class width. Similarly, frequency of median class is 10. Width of median class is 12 minus 8, 4, and we put it in this equation. We get median as 10.4. Once we get the median, we can directly put it into this equation and get mean deviation of median for a continuous distribution. Now we come to a very important term called as the variance and standard deviation. So we have found earlier that mean deviation means sum of mod of deviation. Mod means finding the absolute values. This we have seen earlier. Now instead of putting a mod symbol, we take square of that. So x minus x bar the whole square. So this number will always remain positive. This also is always positive, but now we are taking square. So this is calling as sum of square of deviations. So now we come to the formula variance. Variance is, this is sigma square equal to 1 over n sigma 1 to n x minus x bar the whole square. So this term sigma square is called as the variance. This term is small sigma and this term is capital sigma. Those are two different sigmas. Like in English alphabet we have small a and capital A. Similarly in Greek alphabet this is a small sigma and this is a capital sigma. So sigma square, which we are using here, sigma square. So this is for variance. Whenever sigma square is given, it is called variance, and its formula is given by 1a sum of square of the deviation. This capital sigma is summation sigma. So if we have, let's try to understand this. So if we have sigma xi, it means x1 plus x2 plus so on till xn, where I equal to 1 to n. So capital sigma means we are adding the terms. See, they are the summation terms, whereas small sigma refers to the variance term. So whenever we say variance, it means sigma square, and if we take square root of sigma square, we get sigma. Now taking square root on both sides, we get sigma equal to square root of 1 over n, sigma equal to 1 to n, x minus x bar the whole square. So what does it mean? This is called standard deviation. Small sigma is standard deviation, and small sigma square or simply sigma square is variance. So first you have to compute the variance in your problem and then take a square root of the variance to get standard deviation term. This is very important topic in statistics which will be using throughout your future classes. Now let us try to find the mean and variance of this particular data. Data is 6, 7, 10, 12, 15. So first is to find the mean. Mean is simply adding these terms and divided by number of terms, which is 5. So this is equal to 10. So mean is 10. Now we need to find the sum of square of deviation. So first we will find xi minus x bar. X bar is 10. So 6 minus 10 minus 4. 7 minus 10 minus 3. And so on, we get like this. Now we find the square of this. So 4 minus 4 square is 16. The advantage of putting a square is that now the numbers will not cancel. Earlier we have seen in the mean deviation about the mean, we see that sometimes these numbers are getting cancelled and we'll get 0. But when we take a square, this number will never get cancelled because all terms will be positive. So now we add all these numbers, which is 54. So sigma square is this formula, this term addition is 54. 54 divided by 5 is 10.8. So this is the variation or the variance of this data. Suppose you are being asked to find standard deviation, then just take square root of 10.8. That will give the standard deviation for this data. Now we are going to summarize this formulas what we have used here. This is variance for a ungrouped data. We just now previously saw this 1 over n sigma equal to 1n x minus x bar the whole square. This is for variance, and for standard deviation we simply take square root here and denote it by sigma. Similarly, for a group data, this will be 1 over capital N sigma equal to 1, and we multiply, we see that with the term Fi, and capital N will be sigma Fi. Similarly, a standard deviation will be simply taking square root of the right hand term. Friends, with this we conclude this video. Please like and subscribe my channel so that in future videos can be released to you instantaneously. Thank you very much, friends.